to start I think the 12th week. It's the 12th, I guess. So before we start, I'd like to check our schedule for the rest of the semester. So today is the 7th of November. So today we are going to cover the Cassandra, then followed by your demonstration of page 3. So for each team. So it is just demonstration. You don't have to present entire the project. So to save time, so use the laptop or the computer in case if you are able to demonstrate online, so you can use the computer on the podium. During the break time, why don't you check the laptop whether it can be connected to the projector. A lot of time fail such a connection. Then I want to explain what you guys need to do page 4 after page 3. Then the next week we are not going to have I heard that the last time we had the problem of the MongoDB, the exercise lab. So next week we will do the exercise lab for both the MongoDB and Cassandra. Okay, not today, but next week I'm going to invite one of our the student who graduated from the technical management 2012, I think. Who is Wei Wu. He's the founder of the blockchain, the startup company for blockchain. So it's in the Wilmington. I never so around Wilmington. That because of that, the name is like that. Anyway, so somewhere in Connecticut. He is the founder of the startup company. He is developing the blockchain related to the product. So he will present what he is doing in the company. Then maybe the short presentation around the 30 minutes. So it may be a good opportunity to see those who are thinking about the startup company. Based on your knowledge or research, it will be the good opportunity. I don't think it's not related to the NoSQL database. For example, in the blockchain, using the blockchain is kind of the primary, the kind of the basic, the technology can be used for the many areas. So including operating system and not only security, not only the cryptocurrency, but many others. So one of them is database. So because it's a decentralized the data storage. So we can actually blockchain itself is not centralized, it's distributed. Then we can keep the security like that. So based on that, there are some NoSQL database based on such as the blockchain technology, like the blockchain DB. I think the blockchain DB actually started from the 2016 or 15. No students like such a DB. So I think the blockchain technology also related to our NoSQL database. So then followed by the exercise lab. For the MongoDB and Cassandra that we are going to cover today. But he graduated from the technical management, not computer science. Then, so we have the Thanksgiving holiday, 21st, so we are not going to have any class this week. And 28th, so we have 2 more weeks after Thanksgiving. 28th, Maria will prepare the NoSQL database based on the GCP, Google Cloud Computing, so platform. So I think one of the students used the online cloud-based NoSQL database, but nowadays, as we have seen the last class, MongoDB also supports the cloud-based database as a service. So mostly it's a spanner of the Google that you researched on the last time. But if possible, any other NoSQL database supported by the Google GCP will be discussed in the next class. Not next class, the 21st week, the class. Then 28, we will have the final midterm, final whatever, the exam, the shortly. So it will be the small, the exam is not huge. So basically, I'd like to check the basic knowledge on the NoSQL database. So if you already attended the lecture and did the project, I don't think any problem. So you don't have to prepare for the exam. But anyway, exam is the exam, so we will have the maybe less than hour the exam, and followed by the oral presentation. So page 4, moving to the page 4. In the page 4 is basically presentation of the selected NoSQL database research and implementation. So there are different types of presentation. First one is writing up. So you are going to write the paper based on your research and the implementation. Okay, should be formal writing for your experience. Please use the I3 or ACN, the technical paper template. So you can find easily from the Google Internet the I3 2-column format that you have used for your proposal. Please use the same template for your technical writing skill. And that is the writing up. Second thing is the oral presentation. So just like what you presented before, after the page 2 or the other, so it should be formal the presentation regarding to the research so far and the demonstration. So it's a group presentation, which means you can take turn, half and half, or the one student present and the other student take control your PPT file or demonstration, something like that. It's totally up to you, but each team will have the less than 10 minutes. Longer than 5, less than 10 minutes. So that will be 1.5 hours because we have 10 teams. In case we need more time, we may meet one more time, but I will try my best to finish all 10 presentations by the end of the class. It's December, I think the 5th. That is the last class. Then, during the final exam week, that is the 2 presentations. One is the writing up, second is the oral presentation. Third one will be the poster presentation. So we are going to have our own poster, the workshop. So I need your help because right now the UB printing service is in charge of printing all the poster, which means they should be ready at least 1 week before our workshop. So we are going to set up the proper time slot. It's a daytime, not the evening, during the evening, so nobody comes to see the poster. So I'd like to set the probably during the lunch hour, one of the day during the final exam week. Then we will have the maybe 1 hour, 2 hour workshop. So we will display the poster like what you can see from the engineering building. So we mount a lot of posters. So we have 10 teams, so 10 posters will be displayed. Then you are going to invite your friend or the faculty or whoever. So then I'm going to judge your poster based on how many stickers you will get. So I'm going to hand out the 5 stickers for each the visitor. So you can invite your friend, then they will put the sticker if they like the poster. So the sticker, the poster that receive the most sticker will get the first prize, second prize, and that will determine your grade. Okay, so please bring the more friend finder. But the more important thing is the quality of the poster. The poster requirement is the same as the poster requirement that we have used in the internally on campus or the ASE campus, which means 24 inch by 36 inches. So you need to prepare the poster, either PPT file or PDF file. Image may be possible, but I strongly suggest to create your poster based on these 2 formats. Then should be ready. Then some templates are available on the campus. If not, I will check. Bavia, why don't you check? I will upload several templates, but you can see some of the example from the posters mounted on the engineering building. So 3 of them will be evaluated. Then the project will be finalized. So for the final grade, so most important part is the project. Okay, so 1, 2, 3, and 4. So this will be around maybe the half or the more than half, the 50 to 60% of your final grade. The other will be the handling of the classroom assignment or homework or the reading assignment, as well as the midterm exam. So this will be the overall thing that we are going to do rest of the semester. So please be ready for today's demo. Then I will and the GA will give the more comment advice to enhance yours. So also one more thing. If your paper is recommended by me or the GA to apply the ASE conference that will be held in the University of Buffalo, the spring, the semester, the due date to submission of the abstract is the beginning of December. So I strongly suggest to you guys, so if you are suggested by me or the GA, you will get the extra point. And if you submit the abstract, then anyway, so more reward coming in. So please try to. I'm going to forward that the call for poster participation email to you. Some of you guys already received, right? ASE conference 2019. Did you receive? The due date of the submission of the abstract is the first week of December. So please be ready for that. You don't have to submit the poster at the time, just the abstract, so you still have a chance to enhance even after this semester. It will be a good opportunity if you are selected. Mostly based on my experience, global engineering support the transportation and the registration, so it may be a good chance to go to the Niagara Falls. Okay, it's 8 hours driving, so I don't know how to stay over there. Okay. Any questions? Is it too fast? If you do not get the point, please ask your friend or ask me again. Okay? Then today we are going to where is it? There. Another well-known NoSQL database, which is Cassandra. Have you ever heard about the name of Cassandra? What is the name? No? Anyone? It's from the Greek myth. It's the princess, daughter of the Troy. You heard about Trojan something? It's one of the princesses. Then sometimes she is called as a curse of oracle. So oracle means it's something said or the future like that. If you watch the movie, Matrix movie, there's an oracle. She is representing something, talking about the future, whatever, predict, and so on. So, you know, the oracle is one of main, the DBMS, the database, the management system, and the company. It's like because of the, I guess, it's named as a Cassandra, the curse of oracle, something like that, maybe related. So, actually, this Cassandra is not new one. It's really very, very similar as HBase. Also, we talk about the DynamoDB, which is one of the popular NoSQL databases, specifically based on the AWS before. So this Cassandra, the NoSQL database, was developed by the Facebook. Especially in the Facebook, they need to manage. How many of you guys are using the Facebook Messenger? I installed. I'm not using a lot, but even though it's not much used like the FaceTime or whatever other, the WeChat, what other the messenger are popular? The WeChat, WhatsApp, whatever. So especially India has their own something popular. China has their own popular. Korea has it. The Apple, but it's not that popular. But still, a lot of users use such a Facebook Messenger. So they need to retrieve very quickly such a message. Even though it's not the messenger, their size of data is huge. So to address that problem, first time Facebook used the relational database to store the messenger, the message. Okay, then quickly realized that the relational database has that takes the time to search the data. The serious problem is the size. The MySQL, the relational database cannot keep such a size. So why not developing their own database system? That is Cassandra. So Facebook actually developed the Cassandra. It's not fully consistent. They don't need the consistency. Like that may take a time to update and keep the data. And also, even though I'm sending and receiving such a message through the messenger, sometimes I try to retrieve the previous message. How many times? Rarely use. So we don't have to the really real time or the quick response time searching such a messenger data. Only the latest one should be updated quickly. So considering such the characteristic of the messenger, the data, they developed their own NoSQL database. Definitely it should be distributed, and also it's quick, but we may lose some consistency. So that is by combining HBase. HBase is a column based, and it's the database, the NoSQL database, on top of the HDFS distributed system. Also the DynamoDB on the AWS. So we have seen the DynamoDB is a really scalable the database, the NoSQL database. So by combining both of them, then they developed the Cassandra. Then finally, they actually open their code to the open source. Then put into the Apache Foundation project. Is one of the core, the Apache Foundation project. So still, it's a current new version is released. I think the current version is 3 point something. But to understand the very basic architecture of the Cassandra, the old version that you are going to use on the Brilliant is also fine. So, but just like the MongoDB that I introduced last time, you are able to download and install such a Cassandra from the Cassandra website, then test it. Especially the Cassandra provides a nice interface like the SQL, which is called the Cassandra Query Language SQL. So using the SQL, so MongoDB, many of the NoSQL database like the MongoDB, they do not provide the query language. Instead, they provide the interface because that's faster. But we actually spoiled. So we are spoiled. So we are familiar with the query language, SQL style query languages. So Cassandra provides such the query languages. So we will see quickly what is the Cassandra, the NoSQL database today. So it's basically the distributed key value store. So if you remember the HBase as well as the DynamoDB, the DynamoDB definitely key value. Even though we classify the HBase as a column-based database, actually their data are stored as basically key and value. So it's based on the key and value. It's a high availability, which means what is SPF? Single point failure. So there is this distributed one, so it's no single point of failure. For example, think about the HBase. HBase has the master node, master server, to control the region. So if you fail, if you have a failure of the master node, so you lose all the data, all the system like the HDFS. But this one, there is no single point of failure. So in other words, it's very high availability, 88. And also it's scalable like the DynamoDB. It's a linear scalability. Linear scalability, when we see such a linear, it's better, but the linear is really hard to get the linearly scalable the system. The more node you have, the better performance, but actually it's not that simple because it's more and more complex to manage a number of nodes. So it supports the linear scalable, but they actually a little bit sacrifice the consistency. As we have seen in the cap theorem, we cannot keep all of them. So they had a very high availability. So it's A, and the partition is for the linear scalable, which means we cannot keep the consistency. Instead, this one is called the eventual consistency. In other words, it will take a time to. So because of such a high availability and the linear scalability, probably they will have the replication of the data, several, like the HDFS. So 3 or 4, you will see such a replica. So that means, so we cannot update all 3 or all replica at one time. Instead, the one of them the copy, then eventually the copy. So that is the eventual consistent. Okay. So it supports the AP. However, if you keep the consistency, that means you may lose the availability. But you can have you can set up such a strong consistency for using the Cassandra. Yeah, it's based on the column like the HBase. So we will see the data model, column-based data model. Basically, the Cassandra is it's not the new architecture. The developer of the Cassandra in Facebook, they use the HBase. So definitely it's from the Google Big Table, and DynamoDB from the Amazon. And because of that, they still use a lot of inside the architecture of the Cassandra is very similar as the DynamoDB. We will see the replica of the data and also the distribute the data. There, the architecture are almost the same as the DynamoDB. In terms of data model, they adapt the idea of the HBase, like the column family. If you remember the column family, the HBase does not have the schema, it's a schema list. So whenever insert the data, you can actually specify the column. So column actually is not the column that we know from the relational database. Instead, it's kind of description of the attributes. So they use, and also you will see you can select distributed how to distribute the data. At that time, actually you can sort the data like the low key in the HBase. HBase is low key is the index. It can be sorted by the low key. So the architecture data model is from the HBase. So it's a combination of the HBase and Amazon. So here's the Cassandra. You can find the image from the Google. So it's actually the daughter of the king and queen. I was not very interested in the Greek myth, but if you like it, probably you heard about. So anyway, naming in the big data system are sometimes funny, sometimes weird, sometimes this is from the Facebook. Specifically, it's for the Facebook Messenger, the message. Okay, nowadays, it's used the many other company. Okay, actually, the Facebook nowadays they are no more use the HBase style, which means they give up the HDFS style, the file system, file system. They enhance the Cassandra and the usage. So current version, I just checked last week. It's a 3.11. Okay, it's released August 2018. So Cassandra basically used the TikTok developing model. So have you ever heard about the TikTok model in software engineering? What is the TikTok? It's a repeated TikTok, something like that. Intel actually the proposed such an idea to developing the microcontroller, the CPU chip, the developing model, which means whenever we have a new technology to adapt, this is a kind of the momentum of the new technology. Then to do that, so we should release, okay? Release. So this time then, well, fix. Probably this one is not perfect. We need to fix. Then this is a tick. If the taste, then how about the taste? Is it good or not? Then the next stage, so by fixing the major, this is a minor problem, and by fixing the major, so you can at certain time fixing the minor problem altogether. Then at certain time you need to upgrade. Otherwise you cannot solve all the problem. So it's a talk pace, tick and talk, tick and talk. So basically the Cassandra uses such a developing model that is the even number, odd number is like a tick. Okay, it's a minor, the patch minor fix, and the even number is the major, the changes. Okay, so nowadays that makes sense, right? Even though we do not use such a thing, such a tick-tock developing model has been used actually intuitively a lot. So it's officially proposed by the Intel, the group. So it's Cassandra uses such a tick-tock model. Okay? So that is the reason. If you see such a tick-tock, it's the officially used in the used terminology, especially software. Now I'm not sure it's that is the software engineering, but definitely it's the processing management in the technical management major. Things like that. Okay. So you can download from this website further. So it's for the inbox search, it's actually the study from the inbox search. So Facebook first time they used such a MySQL relational database. They realized wow, so you cannot address the problem of the response time as well as the scalability. So to support the latency and scalability, let's take a look at the example of the messenger. So this is a two user ID, 2249 and 911. Whenever we send and receive the message, there are two users. So forget about the 3 or 4, the multiple user, the messenger or chatting room. It's just the two user. Then we can later extend. So we have already erased the one user who sent and another user. So we can put the smaller ID user and the higher number ID user, like this one. Then we can define the model of the message, like who is the sender, who is the receiver. Okay, who is the sender and who is the receiver, like that. Okay, sender and receive and recipient, and sender and the recipient, and so on. So when we search the such a data, we want, if you want to search all the data, first you'd like to see the message from the latest one, right? So if I turn on, then the turn on, I want to check the message. So it's from the latest one is the bottom, the first one, and you want to scroll up to see the old one. So which means they are stored separately, the old data. This is the talk, the message current talk. This is the last message per user. So they actually separate the current message, which requires fast response time, and the old message that doesn't require such a. Otherwise, if you consider all the message together, it will take a really long time. So somebody may say that we can develop such a message storage using the relational database. Yes, you can. So it may work. And for what about you have the billions of users, then each user generates 10 messages per minute, and it will be huge. So to address that, so they separate the column family. So one is the talk message. It has a number of such a. And another one is the talk last message history, kind of history message. Then if we need it, we can access. So to define the two column family. Then each column will be, it's not like the message or the time. It's a combination of the sender and recipient is the column. So that is the reason it may support 2 billion of column. Actually, column is not the column that you think. It's also another, the data. So we can have the 2 billions of the data for the one talk message. Then for each user, we can manage the number of the message history. Then we can retrieve. So this is kind of modeling that they think. So to keep the such data, so they adapt the idea of HBase. HBase is a column-based the database model. And however, this is huge, so we can use the HBase for the such a scalable. But it's not that the satisfied, so they consider DynamoDB architecture for better scalability. So that is the motivation of the Cassandra database. So we will see the Cassandra based on this. So as I said, for the scalability, is the data partitioning is required. Data sharding. There are different ways of data sharding, data partitioning. And second thing is for the availability, high availability, we need to have the several copies of the data. That is called the replication or replica. Then the data model we have already seen is column family based. Then read and write, how to support the read and write. So do you remember how to search the data using the DynamoDB before and the HBase? I think the HBase we talked about. Bloom filter. The Bloom filter doesn't guarantee, but at least if there is a data, such a Bloom filter is a true positive, is okay. Even though maybe possible no data, it's a false positive, but the true negative is not happen. So using such a Bloom filter, we can read the data. So then the consistency level different. The level of it's called the tunable, the consistency. So if you want to strong the consistency, actually you can set the one copy. You may lose scalability or high availability at the time. Okay. So for the first partitioning, it's like the Amazon DynamoDB. We are going to. So partitioning means we are going to distribute data. So how to distribute the data? So DynamoDB uses hashing. So we can use a random. There are two types of partitioning. One is random partitioning. Random partitioning, we are not going to consider any order of the data. Instead, using the hash, we can evenly distribute the data. So that is the main focus. On the other hand, the byte order partitioner, byte order partitioning means we are going to the partition sharding based on the order of the data, which means the data should be sorted. Okay, so A to C is the first partition, D to F is the second partition, and so on. So whenever we decide the location to store the data, you need to find the proper location based on the ordering, which means you may lose the performance because you always have to find the proper location. Second problem, your system may not be balanced. So there might be a lot of A rather than Z. Okay, so it's not balanced. However, we may get the benefit of the byte ordered partition when we are doing range query, or when we search based on the key. Okay, so probably the Facebook developer, they thought about the reason. So we are not going to develop the general query, the query system. Instead, only focus on such a key. Mostly we search the message based on the key or range query. So because of that, such a byte ordered partitioner is working. So quickly see that. Oh, also they are using ring topology. Ring topology means we are going to consider partition node as a ring. So if there is A node and the B node, so if we have the key A to B, okay, so it's owned by the B. So A starting A or anyone, so A to the B belongs to B. Then copy of, replica of the key A through B will be C and D, the next node. If you have the 3 replica, always next. So in case of key B and C, it's a C and a D and E, like the 2 next. Then the benefit, so if for example B is failed because of the network failure or the system failure, in case of B is failed, the ownership of the key A and B will be taken by the next, always next, because it's a ring topology. The next node should have the replica of that. So this is the ring topology. So used in the DynamoDB. Then the Cassandra also the idea of this one. So use the same thing. So random partitioner use hash value. So it's even. So random does not mean really random. It's based on hash key. Okay. So that is so it's called the hash ring. So mostly it's even uniformly distribute the data. It's a balance. So in case of the hash function, the key function is a hash, so we can calculate the 2.6 that belongs to the here. So node 3 is the owner of the up to the 2 less than 3, then has a replica of this to the next and next node, and so on. Okay. So however, byte order the partitioner use the sorted data. So if we find the location, we need to find the proper location of the data. Okay. In other words, sort the data. Okay. We can use the low key. Okay. Then we can use the benefit of the key for range query or specific query. Okay. The problem is maybe skewed data unbalanced. Okay. So that is the partitioning used in the Cassandra. So also Cassandra adapt the idea of the virtual node used in the DynamoDB. The virtual node means let's say that we have the 1, 2, 3, 5, 6 nodes. So we have 6 nodes. So each node has the value. So we have 3 replica. A is here. Another A is the next one because it's the next node has the replication of the data. So A is in A and the B is here. C is so like the A and B and the C like this. So we are going to, for example, if node 5 is failed, we can get the E from here, D from here, the C from here, from the 3 nodes. Then we can restore. Okay, something like that. But what about the other nodes? They are not fully utilized in case. So to get the fully benefit of the distributed data, one node will be divided into the 2. So how many nodes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's like 18. How many? 8, 2. So anyway, so we are going to divide the one node by the several nodes using virtual. So we regard such the additional node as a physically it's one node, but virtually we regard one node as a multiple node, like this one. So so we can divide the data partition more precisely. Then A is here, and A is here. And so more the partition. Okay. In case of failure, then we can get the full benefit of the other server. Search is the same thing. Okay. So this is called the virtual node, the topology, like this one. Okay. So that is a partitioning using. Basically, it's very similar as the DynamoDB. Replication is you can keep in mind the NoSQL database is not personal purpose. It's not just the terabyte size system. Instead, it's a really big, huge amount of data like the Facebook or the AWS and the other. So, which means we need like the rack style data center. So one data center located in the New York, another one is maybe LA. It is true, if geometrically the very far, there might be network latency. It will take a time. So we do better access the data from nearby, just like the GCP, Google Cloud Platform. So if you create the system, virtual machine, nearby the northeast, you need to pay a little bit more. But if you create the exactly same thing, but for example, the not much used server like the Europe or whatever, it's so cheaper, even though you create the same thing. Because if you create some other place, you may lose something, you may have the latency. So the replica should consider, one is without considering such a data center within the same network. So we can make the replica of that. So A1, A2, A3. The B1, B2, B3, and C1, C2, C3. And if where is that? So we have. So it's within the within the data center we can create the replica using the ring topology like this. It's called the simple strategy. Okay, but if we have the multiple data center, that's the more reliable, like the New York and the LA, something like that. We need to consider such the data center, so network topology strategy. So at the time, so even though it's a ring topology 1, 2, 3, 4, 5, 6, 7, and 12, but the 1, 2, 3. So and 1 is a topology. It's like the architecture, not physically located, but you can see the physically node 1 and node 2. Even node 1 and 2 are in the different rack. Then that makes sense because we are going to make a copy of the replica 7 and 2. Which one is better? To make the replica 1, 3, 5 or 1, 7, 2. The later is better. In case entire center is down, we still have the node 7. Or if the failure of the rack, this one, we still have the node 1, the data. So in the topology, the design, we will keep the every other. You can see every other for data center and every other the rack. Then design, then make the replica. This is a network. We can consider the network, the topology to create the replica. Okay, so this is the two strategies of that. So we can skip the snitch. There are a bunch of different ways, but there's too much the specific the strategies for the replication. Regarding to the data model, is from as I introduced, is H-base, which means column family. So what we need to do first time is designing the column family. But the column, it can be a number of the column. As you can see the Facebook message example, is the user 1, user 2. That is a column. User 1, user 2, 3. User 1, user 4. And the user 10, the user 1. Something like that. Combination of that will be the column. So we have the number of column for the column family. But such a column family is the kind of the category of such a column, like the latest message or history message, like that. Okay. So as we can, this is very similar as almost the same as the H-base data. The model is we have key, then the column family. This is a one column family like the profile. And this is a demography, like that. And it has the key to access data and the number of column and number of column. Also, if you remember the H-base also support the versioning. The same data but different time set. So that idea also adapted to the message, because if you think about the message, it's along the time. So actually the Cassandra support the special column, which is the counter. Counter means the Facebook. Think about the how many new messages. It's based on the how many unread messages. So it shows the 1 or 2 with the red color. Then that count, instead of accessing count really the how many messages you receive, instead we can just add a column. So whenever we have the new message, that the column, the counter will be increased automatically. We don't have to use the application level, the counting. Instead, the column itself is the counter. So that is the special column. So counter column. It's used a lot in the message. So if you do not read the message, you can see the number. So you have the 10 message or 100 message, something like that. Also, another column is a super column. Super column is, if you remember the composite attribute in relational database, address consists of the city name, state name, and zip code, like this one. So it's a column family. The super column is like the address by combining a number of the column. For example, in case of a messenger, it's we have the user ID 111. So column is column 111 to the 112, 111 to 113. And then by combining all of this message, this is the 111, the column, super column, like that. So that is a super column. It's the kind of the type of the column for their specific purpose in the Facebook. And also, some of the column has the time to live. But this is a TTL, time to live. It's the expiration. So after the month, it will move to, after the hour, the column move to the history column family. Column in the current one will move to the history. Okay, so it has a time to live. So it's the tombstone after expiration. So it's something the limitation to be available. That makes sense. So if I do not check the message and the day after, it will move to. So if I want to check the after 10 days, it may take a time because it retrieved the data from the history archive. Okay. Then for the read and write, it's also similar as the DynamoDB. Okay. So we are going to consider each node server as a proxy node, so it can direct the where is the data. So if we for example, when we write the data first, it write the primary node. So primary node in this case I3, we have 3 the replica I1, I2, I3. So it write the data to the I3 and return. Then the node ask the another replica to copy the data. So that is the kind of what is that? Consistency, different level of consistency. So it's a level 1. Why? Because it guarantees the one of the node is the strong consistency. In case of multiple data center, so we do the same thing as before. Then the request to the another data center, they will copy. So eventually this node will be the copied. Because of that, it's called the eventually the consistency. Okay. So more little bit detail of the writing. So it's the same as the HBase. If you remember how HBase write the data, HDFS is immutable file, which means we cannot change the file, only the append. So to address that one, we write the data on the region server. Okay. Then to keep the consistency, we use a write ahead log. So we keep the log on the stable storage. Okay, reliable storage. Then update the data on the memory. It's the memory, the mem table will be used. The problem? So what if we have a lot of data? So to the address, when you have the certain amount of the changed data or new data, we will compactation. Flush the file, the data in the memory region server to the file. So Cassandra uses the same approach. So write the commit log, write her head log will be used, and first is the memory structure. The map table will be used. Then eventually it will be flushed out to the SS table. SS table is the same as the HDFS, the table used in the HBase. Okay? So like this is log, this is the memory. So it's like the region server. Then we can from time to time flush it, synchronize to the SS table. So that the SS table is immutable, so we need to do the compactation. We create if we have a lot of data, it should be flushed. Okay, it's basically the same idea as the table used in the Google Big table that you have read before. At the time, the Cassandra used the Bloom filter, the data structure, to search the data. So Bloom filter is basically the multiple hash function. So whenever data is inserted or the existing, then we have the bit stream, then update such a bit stream. So when we search the data, that search apply the same. So data, the query, then apply the hash function, then check whether 1 or not. If 1, there may be data in the table. Okay? The maybe, may not be. So because the hash function is not unique, so it's the collision problem. So different data may have the same one. So this one can be set by the another data. We don't know. However, if the hash value is 0, 0 means definitely no data. So no data return. In case of 1, and search the data. So this is called the Bloom filter, the search. So Cassandra uses such a Bloom filter search. So false negative is not possible, but the false positive. So there might be data, but when I search the data, there is not. It may be possible. That is this one. So this is a Bloom filter approach to search the data. It's all the same thing we discussed. Okay, so it's based on the Bloom filter, and the low level the column index means, if you remember the HBase, so it has a key will be used for the indexing. So then it's only primary key, and we can access the data very fast. And for the performance, so we can Cassandra use the in-memory the structure to read the data very fast based on the cache. Okay. For the consistency, so it's called the tunable consistency. So we can set the different level of the replica. So which means if we keep only one copy of the data, one replica, and then support the strong consistency, which means we lose the high availability because we have the less copy. So that is the idea of the tunable consistency. It's similar as also DynamoDB. So in case of one copy, so we can keep the replica only one, so keep the consistency. However, if we have the n number of copies to be right, so we cannot keep the consistency. Instead, we can keep the availability. So there is in between, which is called the quorum. So if we have the 3 copies, but we will guarantee only 2 copies of data. Once 2 copies of the data, then we return. So you can, even though another copy is not updated, so it will be running. So which means if someone would like to access the data which is not synchronized yet, then should wait until this one is the copied or the different data. Like the message is not. Even though somebody send the message, your message is not the available. Yeah, that may happen, right? So you can see only the something is writing. Okay, it's not actually writing somebody. So if you are using the messenger like the Facebook, the FaceTime or the iMessenger, so if the friend is writing, it shows write something. But actually it's not really writing, sometimes waiting, okay, to retrieve the data. Your friend already wrote the message, but it will take time because our messenger system is not strong, the consistency. For to access the Cassandra DB, we will see the Cassandra query language, which is called the CQL. So it looks like the relational database to use. Interface is very similar as the relational database, so you can easily create the table and insert the data and retrieve the data. So it's not a big issue to use through the Cassandra shell. So you will practice next week after the blockchain talk. Okay. For more information, you can. Nowadays it's less and less the documentation, but still the updated on the Apache Cassandra project. Okay, so we are going to have the 10-minute break. So during that time, so we are going to start from the group number 10 and the reverse order because we did the group 1. Did we? So group presentation is the first. Let's just start from the 6th. You don't